Welcome back to my YouTube channel. Let us see question number 17 that was asked in 2020. It says, find the vector equation of the line passing through the point 1, 2, 1 and perpendicular to the plane. Okay, so this plane is given. We know this is the equation of plane. We have to find a vector equation of the line which passes through this point 1, 2, 1. Okay. So let's start the solution like this. So we have our plane is r vector dot 2I cap minus j cap plus k cap equal to 10. Let us name this as number 1, where n vector equal to 2I cap minus j cap plus k cap is the normal vector to the plane 1. I have just compared my n vector with our general equation for vector equation of plane. So this is my normal vector. The equation of the line passing through the point. So in the question it is given that it passes through the point the equation of the line passing through the point 1, 2, 1 is r vector equal to a vector plus lambda b vector. So I have just written the general vector equation for a line passing through a point. What is this lambda? For some scalar lambda. Now we know that this is the equation of the line passing through a point whose position vector is a vector and which is parallel to the vector b vector. So I can write, since this I have said that this line passes through the point 1, 2, 1, so I can say that my a vector is nothing but I cap plus 2j cap plus k cap. So a vector is nothing but the position vector of this point. And by the general definition of equation of line, we know that this v vector is vector parallel to the line number 2. Obviously, now we have a plane. Okay, let us understand this with the help of a figure. So I have a plane. Suppose this is my plane. Say this is my plane number 1. And any normal vector to this plane will look something like this. Now we are asked to find the equation of that line which is perpendicular to this plane. So let me draw one line here. Suppose this is one line. So this is my line number 2 which is perpendicular to 1. I have to find the vector equation of this line. Now according to my construction for equation number 2, the line number 2, this line 2 is parallel to the b vector. So this b vector will be something like this, parallel. From the figure it is very clear that the normal vector to the plane and the vector b vector which is parallel to the line, they are parallel. Now I can say that since line number 2 is perpendicular to plane number 1, therefore this b vector must be parallel to the normal vector. Very clear from the figure. So by definition of parallel, I can say that this b vector will be some scalar, say mu, Since we have taken lambda here, so let us take mu here into n vector for some scalar mu. So now my equation number 2 becomes, the equation of the line becomes r vector equal to a vector plus lambda into mu times n vector. So let us just put the value of a vector, it is I cap plus 2 j cap plus k cap, and let us name this lambda into mu, this scalar, because lambda is scalar and mu is also a scalar, so their product will be also a scalar, so this will be say nu. And this n cap, n vector, we have just know that this value is 2 I cap from here minus j cap plus k cap. So if I put the value here, this will be minus j cap, will be 2 I cap minus j cap plus k cap for some scalar mu is equal to lambda into mu, which is the required equation of the line. Thanks for watching.